Today we are looking at question 8 of the Prelim physics paper of 2022. So here's an interesting question. Question 8. Learners perform an experiment to determine the internal resistance R of a battery. They use a variable resistor as the internal resistance as shown in the diagram below. There's an internal resistance, there's a voltmeter, there's a variable resistor, there's an ammeter. Switch S is closed. Readings from the voltmeter and ammeter are recorded after each change of the resistor. Use the information on the table provided to plot a graph of potential difference versus current. Use the graph paper supplied at the end of the question paper. Okay, so this is a question that you should draw a graph. Usually they'll always ask you to draw one graph in the paper, so you should get used to it, seeing what they're asking you. So what we do is take the graph paper that we have, graph of potential difference versus current. Okay, so we must, let's say question 8, let's write on question 8. Question 8. We draw a graph of potential difference versus current. Right? Okay, so that's the graph. We'll have to draw the graph. So let's just see what we can do. Got our graph going down. Another one going across. So let's just put in our values here. How do we put in our values? We'll have to see what values are given. We got potential difference 0,5, 1, 1,15, 1,3, 1,5. Okay, so that's a bit of a challenging one. So 0.2 maybe, 0.2, 0.4, 0.6, 0.8. Yeah, you can do 0.5, but 0.5 will be too big. 0.1 or 0.2. So 0.2, 0.4, 0.6, 0.8, 10. We can go to 15. So we must go to 1.5. So then this graph is a little short. We must make it a bit longer. Let's just see what fits. So right here, 0,2, 0,4, that's at this point, 0,6, 0,8, 1,0, 1,2, 1,4. I think we should even go further up, make it 1,6 here, 1,6. I think that will be better. Let's just see if we could move this heading. Yes, we can move this heading. Let's just take it a bit higher up so that we don't interfere on our graph. I'll just put it there. And then here we can go to 1.4 to 1.6, right? And then on the other side, we'll have to look at our values that are required. It will be 0,0 milliamperes, 1,31, 2,2, 6,5. So then there we can go in milliamperes, 50 maybe, 50, 100, 150, 600. Let's just see, let's choose a value. 350, 400, 450, 500, 550, 600. Maybe yeah, that would be better. We'll make it 50. Let's just draw this line to become total there. Let's go even further. Let me see that we'll have to bring it slightly down. Okay, let's just make our values here. This will be in milliamperes, so this will be 50. This is 0, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. Okay, that's what we've got, and what we should say, we should label the axes. We can say this will be current, and it is measured in milliamperes. That's important. And on the other side, what do we have on this side? We've got potential difference measured in volts, so that we should also write that there down. This is going to be a difficult one. Let me just see if I can do it. Potential difference and what you should say it's measured in volts. Okay, I found it difficult to write on the sideways, but basically you know what to do. You put your heading, you put an axis, the label on the axis, you must put the unit on the axis, on the y-axis, and the x-axis you do the same, current measured in milliamperes. You collaborate it properly. Alright, and then from there you can basically work out your values. So you use the graph paper provided, right? This will be there, and this will be there. Continuing. Right, so let's look at our values that we have, then we can take it from there. Okay, 0 milliamperes, 1,5 volts. So let's write that down. It's 0 amperes, 1,5 volts. That will be around there. Okay, the next one will be 1,31 1,31 milliamperes, 1,3 volts. 1,31 milliamperes, 1,3 volts. So 1,3 volts and 1,31 milliamperes. So this is 1,3 volts, and then coming down to milliamperes, 131. So that will be 150, 100 to 150. So 131 should be around there. 131. Let's just double check it. 131, 1,3, 1,15 and 2,29. 1,15, 1.2. So 1,15 will be around there before 1,2. 105, it's around here, and that will be 1,15 and 2,29, 200 to 250, 225, 2,29 will be here, and it will be 1,19 around there, more or less. Okay, 1 and 3,27. Voltmeter is 1 and ammeter is 3,27. The voltmeter will be around 1. This will be 3,27. 3,225 will be there, and 1, 2 will be there. 2,7 will more or less be there. Okay, the next one will be 0.5 and 652. 0.5 volts. 0.5 volts is here, and 652. I didn't put that down. 0.5, 600, 650 is there, 652, be around there. Okay, so if you just minimize this a little bit, if you look there, we see that we can draw a graph. Let's just put in a graph here, starting at 0.5, and then we're going down, and we see more or less it fits into a graph. Oh. Let's just let me just make the values a bit thicker so we don't mess them out. Okay, it's gonna be a bit of a problem. Let me just leave them rather. Okay, let's see, maybe we'll come right. Line of best fit. Oops. I'm just battling with this line. Yeah, maybe that will be better. Alright, so that will be the line that we get. The line of best fit. That's how it will work. We've got our points that are pointed, 1, 2, 3, 4, 5 points in the line. Best fit graph, it's a negative gradient. We've got the heading, we've got our labels on the y-axis with the unit volts. We got the labels on the x-axis and the unit milliamperes, and we got it collaborated fairly well, so we should be covered, right? So that will be the first question. Let's look at the next question, 8.2. Use a graph to determine the EMF of the battery. So the EMF of the battery is where the voltage is zero. Where the current is zero. The EMF of the battery is where the current is zero. So if you look here, we'll see that the current, when the current is zero, the voltage is 1,5. No current is flowing. So the EMF of the battery is 1,5 volts. So let's write that down. That will be 8.2. We say this is 8.1, let's just write on 8.1. And now we're at 8.2. So the EMF of the battery is 1,5 volts. What was the question? It was 8.2.1, the EMF of the battery. The internal resistance of the battery, so if you have to work that out, say this is 8.2.1, right? Let's just put it 8.2.1. 8.2.2. So if you have to work out the internal resistance of the battery, in this case here, what we'll do is you'll work out the gradient of the graph. So the gradient of the graph, if you have to work out your gradient of the graph, gradient is equals to delta y over delta x. So what's your change in values? You can take different values, and you can come up with the reason. Maybe we can take the first reading and the last reading. So your first reading is 1,5 volts, and your last reading will be 0.5 volts. So we'll take the first and last reading, right? So we'll say final minus initial. We could take other readings, it doesn't really matter. We can say final is 0.5 minus the initial is 1.5 volts. And then if you look at the current there, the current there will be it will be 6, we worked it out. What would it be? 0.625. 0.625. 0.625. Let's just put it down. 0.625. Actually, this last point I plotted it wrong. It will be 0.625. It should be around there. So this point is wrong. 0.625. Let's just fix it just now. We'll fix it just now. So 0.26. 0.625 minus the value there is 0. Okay, so it will be 0.625 minus 0, and then if you work that out, work it out, 0.5 minus 1.5 equals divided by 0.625 minus 0, and we get minus 1.53 ohms. So that will be our internal resistance, but internal resistance cannot be negative, so the internal resistance will be 1.53 ohms. So that will be the answer that we're looking for. Okay, let's just fix up this graph that I did, 0.625. Let me just check that again. There was a mistake here. 0.625 and 0.5. Let's just see if it's right or not. 0.5 is right. No, it is right. I did put it right. It's 0.5 volts. I'm confusing the volts in the camera current in 0.625. This is correct. So yeah, the diagram is correct and the values here are correct. 1.5 volts is your EMF. Your internal resistance is 1.53 ohms. So that will be fine. Okay, now we're looking at is there more questions? Let's just see 8.3. Okay, a conducting wire of negligible resistance is connected between the point X and Y. Where's X and Y now? There's X and Y. So you're drawing, you're putting a current here. So if you're putting a wire here, you're putting a conducting wire here, the current doesn't have to go through the resistance wire. It's found an easier path. Basically, you can cause in a short circuit. So it says here, a conducting wire of negligible resistance is connected between the points in X and Y. How will this affect the temperature in the battery? Right, and only increase, decrease, or remain the same. And then you must explain your answer. Now we're talking about the temperature. So we're talking about energy. So because the current will go through the easier path, there will be a short circuit, right? So we'll have to write down 8.3. How will the temperature be affected? The temperature will increase. Temperature will increase. Now we'll have to explain it, right? So because there's a current because there's a conductor putting there, basically you are bypassing the resistance, so your resistance will decrease, right? So we can say according to W, because we're talking of energy, work and energy, I squared RT, since the R is decreasing, since the R decreases, comma, W as the resistance decreases, the current will increase. Since the resistance decreases, Since the resistance decreases, the current increases. Okay, so we can say the temperature will increase according to the W is equal to I squared RT. Since the R is decreasing, the current will increase. The temperature of the battery will increase because the internal resistance will be affected. Okay, so we'll stop there.